Hi, Dimitri is here with a video about distorting CAN bus signal. It is inspired by a video by ScannerDanner and Positive Lead Diagnostics that YouTube suggested to me in recommended videos. Thank you, YouTube. So the link to the videos are in the description, but the summary is that they were looking at a Volkswagen car and they noticed that one module is distorting the CAN bus signal, and they thought it was bad at first, but it turned out that that module just didn't get power, and the internal circuitry, when the module was powered off, was affecting the signal. And my question is, can we reproduce that? It is suspected that internal protection diodes in the powered off circuitry are distorting the signal. And I've been wondering, can we actually support that theory? And this is the purpose of this video. In fact, we are not even going to use a car at all, because instead I'm going to use a board that has a CAN bus driver in it, and we are going to use it in a lab setting. We're just going to power that module, the CAN bus driver, and try to connect it to different circuits and see what happens to the signal. The module that I'm going to use is called Sparkfun OBDII UART adapter, and the purpose of it is to connect the car through a diagnostic port over here to a computer through a USB port. The CAN bus processing is done by this chip over here called MCP2551, and the purpose of it is to decipher CAN bus messages and also send some of its own, depending on the commands coming from the USB port. So for our purpose, I do not connect it to a car at all. Instead, I just use jumper wires to get the CAN signal to the breadboard, and there I can experiment with what I connect it to. And also the leads are going to my baby Pico over here, connected through the leads over here. And so let's begin our experiment. The first experiment is quite simple. We have CAN H connected to the channel A of the Pico and CAN L connected to channel B. Here I have it assembled on the breadboard. I have the CAN H and L going to the breadboard, and then from there going to the Pico leads. If you're wondering why I don't have the ground for the Pico, is just because my USB connection actually provides one anyway. So, well, ideally you can have one, but it doesn't really matter at this point. On the screen we have 2.5 volts on both channels. What is that? And now we have now we'll issue a command to get us a few messages sent, and hopefully we will see them. Okay, what was that? So, do you recognize that as good CAN bus message? No, definitely not. So I think it tries to raise the voltage on CAN high and lower it on the CAN L, but then that voltage doesn't have anywhere to go, so on some capacitor on a resistor goes back to the regular voltage, but we do not have any good signal. It's all garbage, and that's what you would see if the modules that contain terminating resistors are disconnected from the network. In the next experiment we connect a terminating resistor between the CAN-H and CAN-L lines. I had 100 ohm resistor lying around, so I used it. It technically should be 60 ohms, but it doesn't matter. The circuit is robust enough that it won't really notice that. So you can see that on the breadboard setup I now have a resistor in between the lines. So now what we are going to do is exactly the same. We are going to start the capture and then ask for a few messages on the bus. Okay, so it looks like we have something. And it looks pretty good. The signal is pretty clean, and we will also try to use Pico serial decoding and add let me just add the decoders for high channel A. We don't need the table, only the graph. And we need the low for channel B, and again we need only the graph. And it will try to interpret it for us. So you see that we have now the CAN CAN high channel A, CAN low channel B. We have the numbers that show us the deciphered signal. So this experiment is complete success. We have clean signal that Pico is able to easily decipher. So that's why you need the terminating resistor. To test if the unclean signal is caused by the clamping diodes, we need to make some assumptions about what's inside the module. So here we go. Assume that we have CAN-H and CAN-L coming in, connected inside by a resistor. We have the clamping diodes going both to ground and to the positive plus 5 volt rail. Plus 5 volts is provided by a voltage regulator from the battery power. We have a capacitor and some unknown circuitry, some microprocessors that are powered by plus 5 volts as well. If we have a negative transient, it will get absorbed by this clamping diode, and the positive transient will go through this diode all the way to the battery and will get absorbed over there. We need to simplify the circuit. First of all, we don't have the power, so all this part of the circuit is irrelevant to us. But we need to do something about this unknown load. We can replace it with some resistor. After that we'll get a circuit like this. So we have a CAN-H and CAN-L connected to the positive, well, fake positive rail using the clamping diodes, and this in turn is a circuit that contains a capacitor and a resistor in parallel. So let's see what we have. I have the circuit assembled over here on a breadboard, and we'll see what we have on the screen. So let me start the capture and issue a command to send a few messages. And so we immediately have the response, and what we see that our signal is not clean anymore. We have all those bands that shouldn't really be there, and especially you can see, for example, over here, this is obviously distortion to the signal. Nevertheless, we can see that the picoscope was able to interpret those messages, I assume, correctly. So this distortion is not that bad to bring down the communication line. So the conclusion is that we can have a lot of fun with this CAN bus driver. We can connect it to different circuits and check the waveforms. It is quite possible that the distortions in the signal that ScannerDanner and Positively Diagnostics observed in their videos is caused by the internal protection diodes. But there are probably a lot of other circuits that can cause similar distortions. I hope you found this video useful, and if you have any other theories what to check, which circuits to connect to that driver, please write in the comments below. Thank you.